Hi, and welcome to AP Chemistry Review. It's me, Dr. V, and we're here to work on free response question number 5 from the 2022 exam. You know, it's always a good day to study AP Chemistry, and you can't start too early. In this webcast, we're looking at free response question number 5, which is a short free response question. And you may already know this, but a short free response question in the AP Chemistry exam is scored out of 4 points. And typically, these short free response questions have anywhere from 2 to 4 parts to them. I recommend that you go grab your calculator and have your periodic table and formula sheet ready to go if you don't already have them with you. My suggestion is that you listen to me introduce each part of the problem and then pause the webcast, try to answer it on your own, and then listen to my explanation. The goal is to really help you write high quality answers to the free response questions where you're really showing off your knowledge of chemistry. And that's what's really going to help you the most. And I also recommend that you keep track of your score as you go. Did you earn the point? Did you not earn the point? How can you enhance your answer to really make it clear and concise and really answering the question that's being asked? All important things when you're taking an exam. All right, let's jump right into the problem. The following equation represents the decomposition of dinitrogen pentoxide, N2o5, for which the rate law is rate equals K times the concentration of N2o5, and we're given a balanced equation. A sample of pure N2o5 gas is placed into an evacuated container and allowed to decompose at a constant temperature of 300 Kelvin. The concentration of N2o5 in the container is measured over a period of time, and the measurements are recorded in the following table. So a whole lot of setup here. I do want to point out that we are given a rate law. We're going to end up needing that later, so I wanted to highlight that. Part A says, determine the value of the rate constant K for the reaction. Include units with your answer. So they're giving us a really big clue here that our answer has to have appropriate units. And we had this data from the decomposition reaction, and we had been told in the setup to the problem that the rate law is rate equals K times N2O5. Looking at the rate law, what you can see right away is that we're told the reaction is first order with respect to N2O5. And that's going to be important because when we know a reaction is first order, we know that there's a relationship between the half-life and the rate constant. You can look on your formula sheet, this equation's given. T1/2 equals ln of 2, 0.693 over K. Well, we can rearrange that to say that K is 0.693 over T1/2 over the half-life of the reaction. One of the hallmarks of a first order reaction is that the half-life is a constant interval for that reaction, as long as the temperature isn't changing. The half-life, by definition, is the time needed for half the material to react, for half of the N2O5 to decompose. So if we just look at the first 2 blocks of the table, we started with 0.160 molar N2O5, and then 1.67 hours later, we're down to 0.08 molar N2O5. What this data is telling us is that the half-life for this reaction is 1.67 hours. And if we look at the rest of the table, we see that that time interval remains constant. So now that we know T1/2, we can substitute that into our expression for K and solve for K. So K is 0.693 over the half-life, which is 1.67 hours. That simplifies to 0.415 inverse hours. I do want to mention that you could also solve for K using the first order integrated rate law, since we do know it's a first order reaction. I think this is a shorter way and less likely that I'm going to make mistakes. I chose to use this approach, but it's not the only way to get the answer. Part A for this question was scored out of 2 points. The first point was for appropriately setting up the answer with a correct half-life, and the second point was for getting a correct value with correct units. In this case, inverse hours. Now, I suppose you could have converted your time to minutes or seconds and reported that consistently. What's important is that your answer and your work and your units all correspond. Don't make extra work for yourself. Since the time was given to you in hours, there's no reason why the rate constant can't be in inverse hours. But they had to be both there, correct work with the correct unit, in order to get the 2 points here. All right, part B goes on. The following mechanism is proposed for the decomposition of N2O5. What I see here is a mechanism with 3 elementary steps. The question is, identify which step of the proposed mechanism, step 1, step 2, or step 3, is the rate determining step. Justify your answer in terms of the rate law given. Well, if we go back and look at the rate law, we were told that it was first order in N2O5 and 0 order in anything else. When we're trying to relate this to the mechanism, the key thing to remember is that the rate law is telling us that the slow step is unimolecular with respect to N2O5. What that means is that I need an elementary step that has only one molecule of N2O5 and no other reactants. So if I look at step 1, step 2, step 3, both steps 1 and step 3 involve N2O5. But only step 1 involves only one N2O5. Step 3 has N2O5 and NO. That's not going to work. That would imply that we would be first order in NO in our rate law, and we're not. Step 1 must be the rate determining step. It's the only elementary step that has only one molecule of N2O5 as the sole reactant. And that's essentially what you needed to say to earn the 1 point for part B. There's one more part to this question. If this experiment was repeated at the same temperature, but with twice the initial concentration of N2O5, would the value of the rate constant K increase, decrease, or remain the same? Explain your reasoning. The value of K would remain the same. Why? The value of the rate constant depends only on temperature. As long as we hold the temperature constant, the value of the rate constant will not change for that particular reaction. The value of K doesn't depend on the concentration of the reactants. Yes, the overall rate would be affected, but not the value of the rate constant. And that's the core of what you needed to say to earn the 1 point for part C. Pro tip, just as a reminder, always lead with your answer in these kinds of questions. So saying that the value would not change and then explain why. That's just going to make it easier for the reader to interpret your work and assign you all the points that you've earned. How did you do? The average score on this question in 2022 was 1.32 points out of 4. So that's about 33%. The short free response questions often aren't very high scoring. It wasn't a particularly tricky question if you know kinetics. So if you earn 2 points or higher on this question, you're in good shape. If you found this to be helpful, like the video and leave a comment. And remember to subscribe to my channel. I keep making new webcasts, new review materials, and you don't want to miss any of them. And remember, it's always a good day to study AP Chemistry.